Okay, so in this video we're going to go over last year's 2017 C4 paper. First question is parametric equation one. Just trying to get us into the paper. First is to get expression for dy by dx, given that we know the parametric equation. Right, okay, so what we need to work out is dy by dt and dx by dt, and we're going to use dy by dx is equal to dy by dt over dx by dt. So dx by dt, well, that's pretty straightforward. That's just free. Dy by dt, well, the 5 differentiates to nothing. This is minus 6 to the t minus 1, so taking the power down times by minus 1, so that's plus 6 t to the minus 2, taking 1 off the power. So dy by dx is equal to dy by dt, which is 6t to the minus 2 over 3, which is 2t to the minus 2, or 2 over t squared. So that's the first part done. Part B, it talks about a tangent. I often make sure we clear it's a tangent, so we need dy by dx and we need the coordinate. So dy by dx, when t equals to 2, we're going to need that, the gradient, is, just putting 2 into there, 2 over half squared, which is 2 over a quarter, which is 8. And then we have also to work out the coordinate. So when t equals to half, x is equal to 3 times a half minus 4. That's 3 over 2 minus 4. So that's minus 5 over 2. And y equals to 6 minus, it's not 6, 5 minus 6 over half. 6 over half is 12, so it's 5 minus 12, which is minus 7. So we're then going to use y minus y1 is equal to mx minus x1. It's a tangent, not a normal, so we're not finding the negative of the reciprocal or anything like that. So we just take care here because we know what we're doing, but we've got a y minus y1, that's negative 7, so that's y plus 7 is equal to 8, because that's the gradient, times by x, take away 5 over 2, so that's plus 5 over 2. So multiply out, we get y plus 7 is equal to 8x. 8 times 5 over 2 is same as 4 times 5, which is equal to 20. So our final answer is y equals to 8x plus 13. Okay, so that's part B done. Part C. Well, part C is just to convert to a Cartesian. Probably we best to use t and substitute in here. So from the x equation we get x is equal to 3t minus 4. Adding 4 to both sides and dividing by 3, that gives us t divided equals to x plus 4 over 3. So then we can substitute for t into this one here. So we have y equals to 5 minus 6 over x. We've got this horrible stack fraction, which we're going to like that. So that gives us y equals to 5 minus, flip over the fraction, 18 over x plus 4. We need to get that in the form that they require, it's no good like that. That's equal to 5x plus 20 over x plus 4 minus 18 over x plus 4, putting over a common denominator, So that gives us y is equal to 5x plus 2 over x plus 4. Okay, so nice first question to try and get us into this paper. I think done reasonably well by most candidates. Okay, let's look at question 2. So question 2 is a binomial question. You'll find the binomial formula included in the general one for any value of n that we use in C4 in the C2 formula. But we should know it really. If we've used it enough, it should be pretty clear. Anyway. Right, some of you will recognise first of all that a is equal to 1 over 8 here because it's basically 2 to the power minus 3. But let's just work through it. When it says write down, they normally mean you can write it down, but let's just go through it, and then we're going to need to kind of tidy up and work through it for part B and C anyway. Anyway, we've got fx is 2 plus kx to the power of minus 3, which is 1 plus k over 2x to the power of minus 3, like so, which is 2 to the power minus 3, 1 plus k over 2x to the power of minus 3, and that hopefully shows us, justifies why a equals to 1 over 8. Because when we do the binomial on this, we're going to have 1 as our first term, so therefore 1 over 8. A is 1 over 8. Right, so part B, we can use what we've done here, obviously. So we've got fx is equal to 1 over 8, and let's just do the binomial on this expression here using the formula. So it's 1 plus nx, now n is minus 3. X we're replacing with k over 2x, obviously, so it's k over 2x. And then the next term is minus 3 minus 4. Divided by 2 factorial, or 2 factorial is just 2, k over 2x squared, and we don't need to go any further because we're only going to x squared here. Okay, so now it's just a matter of simplifying. So that's 1 over 8, 1 minus 3 over 2x. Now here we've got a bit of cancelling we can do. That 4 cancels with that 4. It's going to be positive because there's 2 negatives. So that's going to be 3 over 2, 3 over 2 k squared x squared. Now multiplying that out, that's 1 over 8 minus 3 over 16x plus 3 over 16 k or kx, so let's say k squared x squared. Right, okay, so again we can see, if we hadn't seen already, that a is 1 over 8 from what we had before. But anyway, we need to now work out k, and we're using the fact that the coefficient is 243 over 16. So 3 over 16 k squared x, oh no, we're looking at coefficients, so this is coefficients of x squared we're looking at. So 3 over 16 k squared is equal to 243 over 16. Okay, and then the 16 cancels, so we have k squared equals to 81. I think we're told that k is a positive integer at some point. Yep, where k is a positive constant. So we've got k, we know it can't be minus 9, so k equals to 9. Okay, and then for part C, pretty easy. Once we've got k is 9, we're just putting 9 into here. However, having marked this, it's surprising the number who dropped the negative. So the value of b is equal to minus 27 over 16. Okay, so question 3 is a trapezium rule and integration question. Trapezium rule is in C2, and we're quite lucky that we get to do it again in C4. Not that it's the most exciting thing, but quite lucky because it's normally easy marks. Having said that, many people do lose marks. The trapezium rule, don't know exactly, it is in the C2 formula book, but it goes something, it'll be written like this. Okay, now h is b minus a over n, which is seldom used, which, well, students, you don't need to use that here. H is the most common mistake with the trapezium rule is that people get h wrong. H is 0.2. We don't have to mess around with this here on that question, because h is the distance between the bars. Because we've got these trapeziums here. It's basically h is that 0.2 there. Okay, so if we've got a table with the numbers in, we don't have to worry about using this formula. You might want to use it if you're not given a table, but then we want to use it correctly here, because the number of strips here is 1, 2, 3, 4, 5, 6, take away 1. So the number of strips is 5. So you do 1, take away 0, which is 1, divide by 5, which is 0.2. It's a waste of time here, but you might find it useful if you have to write your own table. But make sure you get n correct. And the worst case scenario is when you're given a table anyway, you don't need to use that formula, and then someone goes and uses it wrong. They do 1 divided by 6, and they get complicated numbers, and they lose most of the marks. There we go. Okay, so the area is approximately equal to 0.2 over 2, because h is equal to that. Oh, sorry, I haven't actually worked this value out. It's just a case of putting 0.2 into that formula. Hopefully we can all do that. That's 1.86254. Make sure you give 5 decimal places. Read the question. It wants 5 decimal places. So if you give 4, well, you're not going to get the mark, are you? So there we go. So that's y0 plus yn, that's the first plus the last ordinate. So that's 2 plus 1.27165 plus 2 times by the sum of the middle ordinates. So that's 1.86254 plus 1.78130 plus 1.56981 plus 1.41994. And working that out, taking good care, comes to, and they want this to 4 decimal places, 1.6413. Okay, so that's part A. Part B, oh, we've done part A and part B, that's a trapezium rule. And now we get to work it out exactly for part C and D. So this is a substitution. They'll always give for substitution unless it's a really obvious one. U is equal to e to the x here, and they want us to show that it can be written like this. So we want the area is the integral is 6 over e to the x plus 2 dx from 1 to 0. Right, now to get the, we need to change the values of the limits because we're changing the variable. If x is 1, u, which is equal to e to the x, is equal to e to the 1, which is e. And if x is 0, u is equal to e to the 0, that's is equal to 1. So we're going to have limits of e and 1. So b is e and a is 1 here. Okay, let's deal with the dx. So we've got u is equal to e to the x. We can say du by dx is equal to e to the x, because differentiating. But we want to replace the dx, so we can now write that du is equal to e to the x dx, or 1 over e to the x du is equal to dx. And so that, well, we wanted it all in terms of u, so it would be better to do that now. 1 over u du is equal to dx. The operators are equal to that. Okay, so that incidentally, we might have been preferred to write x is equal to ln u, and then we could have written dx by du is 1 over u, and we might have got it a bit quicker that way. So dx is 1 over u du, but all roads lead to the same place if we use the correct principles, and it's a sensible thing to do, and either of those is fine. Anyway, so we've got dx, so that's, let's bring this over here, run out of space. So we've got a equals to, now we've already changed the limits, that's e to the 1, 6 over e to the u, e to the x plus 2, now e to the x is u plus 2, times by dx, which is equal to 1 over u du. So basically that's it. We've got that equals to e to the 1 over u plus 2, sorry, 6 u plus 2 du. Okay, so that's that, and so that's part C. Pretty simple, really. There's only 2 marks, so I don't think we have to do too much, really. Then part D is to actually work this out. Now it's partial fractions. Okay, now I'm going to use something called the cover-up method. You might not have seen this before, but I'm sure all of us can find other ways to do this. But I quite like to do this in really simple partial fraction cases, because what we've got, that's equal to, we know there's going to be something over u and something over u plus 2. Okay, so that's the partial fraction. And to work out what is under the u, what we do is we cover up the u, use your thumb or something, and what we put in is the value that would make u, that term be equal to 0. So when is this term equal to 0? And of course it's when u equals 0, and we put it into here. So 6 divided by 0 plus 2 is equal to 3. So we have 3 here. Okay, so to work out the term that goes above the u plus 2, cover up the u plus 2, put in what's remaining, what makes that factor equal to 0. In this case it's u equals minus 2. 6 divided by minus 2 is equal to minus 3. So that's our partial fraction. Now it took a while to explain that, but when you get used to it, it can save a little bit of time. But if you don't like it, don't use it. But they are, you can write it out if you prefer. Right, so now we can integrate that term. So that's how I would basically, now I've shown you why that is, I'll just go straight to the actual partial fraction. So that equals to e to the 1, and then that's 3 over u minus 3 over u plus 2 du, using the cover-up method I've just shown. Now we can do lunds. These are both lunds. Now it does wind me up a little bit when people put moduluses, even though that's the general term. We know the limits are positive here, so don't mess around with modular signs really. Obviously it's not wrong, but it's just not required because we know that u is positive. The factors are both positive here. So here we go. So we've got that's what these two are integrated. 3 over, because there's no constant here. Integral of 3 over u is 3 ln u. Integral of 3 over u plus 2 is equal to 3 ln u plus 2. Go from e to 1. So now we can put the e into the bracket. So that's 3 ln e, take away 3 ln e plus 2. Take away, putting 1 in, 3 ln 1. Take away 3 ln 3. Okay, so that's not enough to, obviously we're going to have to, ln 1 is 0, so leaving that there would not be acceptable, but there are many things we can do, to ways we can express this. So that's 3 ln e over e plus 2. I'm going to just using the rule of logs on that bit. Take away, that's 0, it's actually plus 3 ln 3. And now I've got, I think that was good enough for 4 marks anyway, plus 3. That's, as long as we identify that as 0, I think it's okay. But I've got overwhelming desire, as we do, to bring the two lns together. So that's equal to 3 ln 3e over e plus 2. Okay, so that's the answer. Now, you don't have to work it out. It's okay to give an answer for it. I think it's in this question I would work it out as well, because it would be a really nice check to see if this looked like a likely answer, likely correct answer to it. So at this stage I would definitely use this to check my answer, because if I put that in the calculator, we don't want we need an exact answer. But if we work it out, that's 1.64150 blah 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 blah. And then we compare to the trapezium rule that we got before, the 1.6413. They're very close. So at this point, if this were me in the exam, I'd be quite reassured that I haven't done a silly mistake, I haven't messed up anywhere, because it would be quite a big coincidence if I got such a similar answer from the trapezium rule approximation and the exact answer using integration. So I'd be quite happy if that's happened. Of course, the downside is if you don't get the same answer, what are you going to do? So it might be the kind of thing to do strategically at the end, not get too hung up about it, and to, when you've finished all the questions, it's a good checking technique. Okay, let's have a look at the next question. So question 4 is an implicit differentiation question. Before I get on with the question, it's worth, just as a separate thing, talking about how to deal with functions of the type a to the power of exponential functions without e, basically. It's probably a worthwhile thing to know that d by dx of a to the x, not in the formula book or anything like that, is equal to ln a times a to the x. So if a were e, for example, that would be e to the x and ln e, which is 1. If you can't remember that, you just need to be able to get it quickly. So what you can do is just say, okay, let y be equal a to the x. Probably there's various ways of going about this, but you can do ln y is equal to ln a to the x. So ln y is x ln a. Differentiate that implicitly, 1 over y dy by dx is equal to, now this is some constant, we're basically differentiating a constant times x, because ln a is just a constant. So that differentiated is ln a, so dy by dx is equal to ln a times y, which is equal to ln a times a to the x. I know we're dealing with 2 to the y and various things here, but it's really worth knowing this or how to get it quickly in order to deal with these questions, because Edexcel seem to love sticking in exponential functions without e, 2 to the x, 2 to the y, 3 to the x, 3 to the y, or whatever, and we need to be able to confidently deal with it. Just put down red because it's not really part of the question in itself, but we do need to know how to differentiate, how to deal with differentiating 2 to the power of something. Okay, so let's differentiate this with respect to x. We're doing a question now. Differentiate with respect to x. Well, 4x squared, that's easy enough. That's 8x. Y cubed, well, differentiate with respect to y, we're basically differentiating with respect to x, y cubed, which is the same as differentiating with respect to y times by dy by dx. So anyway, differentiate with respect to y, that's 3y squared, and then you times by, because you want dy by dx, you times by that dy by dx. Then we're using the product rule with this. Now some people have to write it out, but don't expect me to. We're differentiating the 4x first, that's minus 4, times by the y. And then differentiating the y, that's dy by dx, or if you like 1 times dy by dx, times by the minus 4x. So that's minus 4 x dy by dx. And now, as I said, we've got to deal with the 2 to the y, which is why I did that. So differentiating 2 to the y with respect to y would be ln 2 times by 2 to the y. But then we need to differentiate it with respect to x, so we times by the dy by dx. So we've used that result basically. And then times by dy by dx because we're differentiating with respect to y. And that equals to 0. Okay, so now let's factorise the dy by dx terms and bring the 8x and the 4y over to the other side. So we've got minus 3y squared, that's a dy by dx with it, minus 4x plus ln 2 to the y. Got to be careful that the ln 2, I'm going to bracket it so it's pretty clear that ln 2 is separate, times by dy by dx is equal to, and say, taking the 4y and the 8x to the other side. So we have dy by dx is equal to 4y minus 8x all over ln 2 to the y minus 3y squared minus 4x. Okay, this bracket here divided into. Okay, so that is a part A. Got a lot going on, which is why there's 6 marks for it, like the 2 to the power of x or 2 to the power of y we had to deal with, and a little bit of work. And then 3 marks for the next part, which is perhaps a little bit less generous with the allocation. We're given a coordinate minus 2, 4, and oh, I see, we haven't finished part A yet because we need to put minus 2, 4 in here first, so that's why there's another couple of marks. So that's minus 2, 4, that's dy by dx equals to 4 times 4 minus 8 times minus 2 all over 16, 2 to the power 2 is 2 to the power 4, 16, so that's 16 ln 2, y squared, that's 16, times 3, which is minus 48, minus 4 times minus 2, so that's plus 8, so that's minus 40, so that comes to 32 on the top, and 16 ln y take 40. So now we really have finished part A, although even then I might just simplify it down, divide by 8 on top and bottom. So that becomes 4 over 2 ln 2, take away 5. Okay, so for part B, we're going to use, it talks about the normal to the curve, somewhere, the normal to the curve at P. So that means the gradient of the normal is negative the reciprocal of this. So that's going to be equal to negative 2 ln 2 minus 5 over 4. So that's 5 take away 2 ln 2 over 4. So that's the gradient of the normal. So now we can use y minus y1 equals mx minus x1. So y take away, now the y coordinate is 4, is equal to m, which is this 5 minus 2 ln 2 over 4 thing, x minus 2. And we want where it crosses the y-axis, so that's when x equals 0. Wait a minute, it's x plus 2 of course, because we've got minus 2 there, so that's x minus minus 2, so that's plus 2. So we want when x equals 0. Okay, so when x equals to 0, we have y minus 4 is equal to 5 minus 2 ln 2 over 4 times 2. So that will be equal to 5 minus 2 ln 2 over 2, cancelling out the 2. 2 divided by 4 is 2. So that gives me y minus 4 is equal to 5 over 2, separating these two bits out, minus ln 2. So we have the 5 over 2 plus 4, so that's 13 over 2, take away ln 2. And we've got it in the required form because it wanted it in that kind of form. We don't need to write p equals 13 over 2 and q equals minus 1. They've just forced us to write it that way, and that's fine. So we've done that. Let's have a look at the next question. Okay, so this is a volumes of revolution question. Not much to it really. We just have to find this volume for this curve. We're given a curve and we're given the limit. So it's a matter of using the formula, which is this, between the limits, in this case b is ln 4 and a is 0, of dx. So v is equal to pi of e to the x plus 2 e to the minus x squared dx from ln 4 through to 0. Now squaring this out, we have ln 4 to 0 e to the this bit squared, which is e to the 2x, plus 2 times this, plus this squared, which is 4 times e to the minus x squared, which is 4 e to the minus 2x dx. Notice this is a constant term. We've got 2 times 2, but e to the x times e to the minus x is equal to 1. So that's going to be 4 in the middle. Okay, so now we can integrate it. So pretty straightforward stuff really. We know how to integrate e to the 2x. We just divide by that constant. And so here we go. V is equal to pi square bracket down, that's a half e to the 2x. And then the 4 times x, that's just that integrated. And then this bit is divide by minus 4 divided by minus 2, which is minus 2 e to the minus 2x. Between the limits, ln 4 and 0. So I'm going to take this reasonably slowly, put it in the limits. Pi half e to the 2 ln 4 plus 4 into the x, that's 4 ln 4, minus 2 e to the minus 2 ln 4. Of course, pi is times by the whole thing, so let's take away pi. Now putting the 0 limit in. Don't really need to go to put everything in like this, but it's taking a bit of care really. So 0 into the final bit here. Right, so now when it comes to dealing with e's and lns, so long as you're confident with this, you know, which you should be, the e to the 2 ln 4, that's, for example, going to be equal to 16, because e to the 2 ln 4 is equal to e to the ln 4 squared using the rule of logs, which is e to the ln 16, which by definition is equal to 16. Similarly, e to the minus 2 ln 4 is 1 over 16. Okay, so those are the kind of things that you need to be able to do without, should really be fine without using a calculator, because it just makes life a lot quicker. So I'm not saying I'd write those down, I'm just trying to explain my thought processes without using a calculator. So anyway, let's just do this. So it gives me v is equal to pi times a half times 16 plus 4 ln 4. Take away 2, as I said, this is 1 over 16 using the rule of logs. Take away pi, and this bit is 1, so it's half. This is 0, obviously. Take away 2. Okay, so that gives me v is equal to, right, pi times 8 plus 4 ln 4 minus 1 over 8. Take away, or that should be plus because of the 2 adds, that's minus half plus 2, that's minus 3 over 2, so that's plus 3 over 2 pi. Right, bringing all this together, we've got 8 plus 3 over 2 minus 1 over 8. So that's 63 over 8 plus 12, so that's 75 pi over 8. And then we've got plus 4 ln 4, or 8 ln 2, probably better to write that. Let's take pi out as a factor of the whole thing. There we go. You don't have to write it exactly like that. There's various possible ways, but it does need to be in some kind of, you need to be bringing together some of the terms together here. We need to work on the lns and the pi's and making sure it's all separate. Okay. Okay, so here's a vectors question. Often find that vectors questions start off relatively standard and okay, and then get tricky towards the end, and this question is no different. First bit's pretty standard stuff. We've got 2 lines, and we're asked for where the 2 meet. Okay, so if we compare these 2 lines, L1, if we write the things together, R equals to 4 minus lambda, 28 minus 5 lambda, and 4 plus lambda is L1, just multiplying these bits together, and L2, 5 plus 3 mu, 3 plus 0 mu, so just 3, and 1 minus 4 mu. I often find students just plough into this, equate x and y's, and perhaps overdo it a bit. Or we can find lambda straight away by equating z. So looking at z, we have 28 minus 5 lambda is equal to 3. So that gives us 5 lambda equals to 25. So lambda equals 5. So that gives us x equals or OX equals to, or the coordinate of x. Coordinate of x is equal to minus 1, 3, 9. We better give it as a row. Apologies, I'm not quite sure why the keyboard thing's coming up all the time. .28 minus 5 times 5, well, we know it's going to be 3 because it's got to be the same as that one. And then putting 5 into that one, 5 plus 5, 4 plus 5 is 9. And it's worth checking to see if it will work. What would the value of mu be for this one? And we can see that in order for it to be minus 1 here, we'd need to have a mu of minus 2. So minus 2 would give us the minus 1, and it would give us the 9 there. And of course we have 3. It's good to do a check on that, but that's all that's required for the 3 marks. Then it says talks about finding the point where they intersect. So it says find the angles of intersection of the two lines, and we want the acute angle where they meet. And it's the direction vector that we're after. So it's those two bits that we need, because that specifies the direction. It does what it says. It specifies the direction, which is what we need when we're looking at an angle. So the angle in between, cos theta, is equal to the two things dotted. So that's minus 1 minus 5, 1, dotted with 3, 0, minus 4, all over the magnitudes of the ones. Now, so the magnitudes of those will be 1 squared. I know I might get an obtuse angle here. I'll just take it away from 180 or change the sign. So that's the magnitude of that one. And then the magnitude of this one is 3 squared plus 0 squared plus 4 squared. Okay, so that gives me cos theta equals to minus 3 times minus 5 of 0, so it's minus 3 of minus 5 times 0 is 0, and 1 times minus 4 is minus 4. This here is the square root of 27, and this is the square root of 25, so that's minus 7, and that's 15, the square root of 3, I think it comes to exactly. And that then comes to, when I work out the angle theta, I get the number 105.6. But obviously what has happened is I've worked out the acute angle. I've actually worked that angle out, so I want the acute angle, which is 180 minus that. Which is equal to 74 degrees. It's actually 74.369 blah blah blah, which I've stored on my calculator because I'm going to need it for the next part or in a subsequent part. So I've stored that number. So looking at part C, it talks about another point X on the line L1. Draw the diagram again. Point A, sorry, on line L1. We know what point X is, we found it already there. -1, 3 and 9 is the position vector of it. That's our point X, and we're given the point A, which is 2, 18, 6 is the position vector of that one. And the first bit is to find the length AX. Well, we can just use Pythagoras theorems for that, or 3D Pythagoras. It's the difference between the coordinates squared and added and then square rooted of that. So the difference between 2 and -1 is 3 squared. The difference between 18 and 3 is 15, square that. The difference between 6 and 9 is -3. Don't really need the -3, but I'll put it in there just for consistency. So that there comes to 9 the square root of 3, which is the answer they're looking for, because they want it in exact form and its simplest form, insert form. Okay, so that's pretty straightforward. The next part talks about a point Y on this is L1 on L2. So, and it says that given that the vector YA is perpendicular to L1, so basically we've got a line coming out here and Y is there, so that this is perpendicular. Okay. So remember, we've worked that angle out already, theta. We know this length here because it's the 9 the square root of 3. So we can just use simple SOHCAHTOA trig to work out YA. YA, because it's opposite over adjacent, so it's opposite times. So that's going to be 9 the square root of 3 times by the tangent of theta, which is 74 point blah blah blah. I say that's why I stored the number on the calculator, so I haven't got any rounding errors. 74.4 something, or 36 something. Okay, now that comes to 55.7 to 3 significant figures. Okay, so as I say, it's getting a little bit trickier, and part E is definitely the trickiest part. So let's do that. Okay, so this is talking about another point B on line L1. We only need line L1 now, so let's do a diagram for L1. X is here, and A is the point we had before. And it says that point B is such that basically the length AB is going to be half the length of AX. Now there's two possible positions that can be in. Point B could be halfway between them, so that this length here is half of this length. Okay. Or point B could be over here. Remember, this is A. Just the same thing. That's going to be half of this length here. It will be half of this length. So we've got our two possible positions for B, which are there and there. Now, a nice way of doing this is various things we could do. We could work out the vector XA, I suppose, and then half it, and then just take that vector away from it, add that vector and take it away to get the two possible values of B, which is a reasonable way of doing it. But as soon as we've got an equation of the line already, which is this equation here, and we've got some values of lambda which are going to be useful. That lambda here was equal to 5. And we haven't got the value of lambda for point A, but the coordinate was 2, 18, 6. In order to get 2, 18, 6 there, we would have to put the value -1 into here. No, sorry, we wouldn't. No, we'd have to put the value -2 for lambda into here. Or would it be 2? It would be 2, wouldn't it? Lambda equals 2. So that lambda equals 2. So because we can see lambda equals 2 to get that from that equation there. Quite simple really, but anyway, lambda equals 2. So we can use this because what happens then is that this is halfway between the two, so lambda will have to be halfway between these two values, which will be 5 plus 2, so that's lambda equals 3.5, the midpoint of those two. And then we can just, well, we can see it's gone down 1.5 there, so we can go down another value, another 1.5 there to get lambda equals 0.5. And then we can put those values for point B into our equation here. So point B is one possibility is 4 minus 3.5, 28 minus 5 times 3.5, and 4 plus 3.5. So that gives us B is equal to 2.5, 10.5 and 7.5. So that corresponds to the point we've got here, where it's in between the 2 points, and then the other one where it's further on. So that's our lambda equals 3.5, lambda equals to 0.5, that's 4 minus 0.5, sorry, that should be 0.5 there, of course, I can just see that there. 4 minus 0.5 and 28 minus 5 times 0.5 and 4 plus 0.5. So that gives us 3.5, 28 minus 5 times minus 2.5, so that's 25.5, and then this is 4.5. Okay, cool. So question 7 is a practical differential equation. Nothing too complicated about it, no corrected rates of change or integration certainly isn't particularly nasty, but we just have to take care and read the question carefully. It's talking about a tank that's been leaking some water from it, and out of the bottom, which is 9 centimeters above the tank or something, whatever, but at some point from the bottom. Now, its first bit is it gives us dh by dt is proportional to the square root of h minus 9 to the half, and it wants that constant proportionality. Now it tells us the water is falling at a rate of 1.1, so we know that dh by dt, and it's quite careful here because quite a few people have been not recognising because it's falling, that means it's minus 1.1 when h equals to 130. So that gives us minus 1.1 is equal to k 130 minus 9 to the power of half, which of course is equal to 121, square root of 121, which is 100, which is equal to 11. So that gives us k is equal to minus 1 over 10. Okay, now for part B, we have we now have the differential equation dh by dt is equal to negative 1 over 10 h minus 9 to the half, and we just need to separate out the variables. Not particularly much going on here. There's no t at all apart from the dt bit, so let's take that over there and take the whole lot of the other stuff over to the other side. So we'll have minus 10 integral, sub the term outside, so it's minus 10 integral of 1 over h minus 9 to the power of half dh, that's that all gone over, is equal to dt, integral of dt. This integrated, well, there's nothing much with that. It's just adding 1 to the minus half. That's a power of minus half. Add 1 to that, that's a half. Divide by that, so it's minus 10 divided by a half. Because we've got minus half plus 1, which is a half. So that's minus 20 h minus 9 to the power of half. And there's no constant in front of h, so we don't have to do anything with that, is equal to t plus c. And we're told that when t equals to 0, h is equal to 200 because it starts off at the top. So that gives us minus 20 square root of 191 to power half. Sorry, minus 20 the square root of 191 is equal to 0 plus c. So that's c equals to that. So that gives us, we're putting c back in and taking over to the other side, we get t is equal to 20 the square root of 191, take away 20 h minus 9 to the power of half. So we want to find out when h equals 50. We can put 50 into h for here, so we have t is equal to 20 brackets square root of 191, take away the square root of, square root of 41, because h is 50, and that comes to 148 minutes to 3 significant figures. Okay, so let's have a look at the next question. We've got given a y coordinate of something that's expressed parametrically, so we can use that to work out the value of theta, and therefore once we've found theta we can put it into x. So we know that y equals to 8, so 8 equals to sec cubed theta. That gives me sec theta is the cubed root of 8, which is 2. So cos theta equals to a half. So theta is equal to pi by 3. Now, so we've got theta is equal to pi by 3 at this coordinate. But we can work out the x coordinate easily by putting pi by 3 into x. So that's x is equal to k, because that's the particular value of x when theta equals to pi by 3 and y equals to 8. So k is equal to 3 times pi over 3 times sine pi over 3. Now pi over 3 is the square root of 3 over 2. So that becomes pi the square root of 3 over 2. So now for part B, we've got we're basically using the parametric equation to integrate. The area, when we're using parametric coordinates, will be between the appropriate limits y dx by d theta between the appropriate limits. So we need to find dx by d theta, and we're going to use the product rule for that. Now, integrating or differentiating, so let's say this using the product rule, let's differentiate the 3 theta, we get 3 times by the sine theta, and then differentiate the sine theta, which is cos theta, times by the 3 theta. Okay, so now we're putting it through into this formula here, so that gives us the area is equal to the integral of y, which is sec cubed theta, times dx by d theta, which is 3 sine theta plus 3 theta cos theta d theta. And now the limits. Well, we know that theta equals to pi over 3 here when y equals to 8 or x equals to pi over square root of 3 over 2. So we know the top limit is pi over 3 because for this one theta is pi over 3. Theta will be 0 for this one because, well, we've got x equals 0, which must mean that theta equals 0 there. Okay, so that's the limits sorted. Now let's take 3 out as a factor because that's our value of lambda basically. Pi over 3, 0 of sec cubed theta 3 sine theta plus 3 theta cos theta, not 3, there's no 3 this time, sine theta, we're taking it out as a factor, plus cos theta, theta cos theta d theta. Right, okay, so now we're trying to get to this bit. Might not be immediately obvious, it certainly doesn't appear to be completely obvious. You might see it, but we might not do. Normally, if that happens, it's not obvious. Not an obvious use of 1 plus tan squared is sec squared or anything like that. It's good to revert, and if you've got mixtures of sines, coses, secs, cosecs, cots, God knows what, you're best off often to revert to sine and cos, which is exactly what I'm going to do here. So sec cubed theta is 1 over cos cubed theta. Sine theta plus theta cos theta d theta. So now divide by the cos theta, cos cubed theta, and I'm going to get sine theta over cos cubed theta plus theta cos theta over cos cubed theta. Taking it quite slowly really, but we need to see how this works. And then that's pi over 3 to 0. Now separating this out, having half an eye of what I need a sec squared theta. Well, I can see that coming here, easy enough. This one's a little bit less obvious, but it's still, if we're looking at tan theta and sec squared theta, well, if we separate that as sine theta over cos theta and 1 over cos squared theta, and here obviously we can cancel the cos theta, so we get 1 over cos squared theta d theta. So now we've got to where we want to be. So that's 3 pi by 3 to 0 of tan theta sec squared theta plus theta sec squared theta, which is exactly, well, written the terms of way around, but that's basically what we've been asked to prove. Okay, so that's part of that. Now the next bit is to integrate that to find r. Okay. So right, well we've got, obviously this should be an obvious case of by parts, and you'll get, if in the exam when this happened last year, I had some quite good students who really struggled or couldn't quite see this one. You will get marks for using by parts on this, even if you can't do this. So always do what you can. Don't think, well, I can't answer this question entirely. You know, do what you can and you probably will pick up something. Let's do the by parts bit. I'm going to do the by parts bit separately with the limits, but leave out the 3 and we can bring it out together at the end. So theta sec squared theta d theta from pi over 3 to 0 is what we want to integrate. It's by parts. So if we let u, if normally unless there's a ln involved, we're going to let u be equal to whatever the algebraic bit is, the theta. So that gives me du by d theta equals 1. And then let the dv by d theta equal to the other bit, that's sec squared theta. And then we get v is sec squared theta is tan theta. And the way the formula goes, it's in the formula book. That's the integration by parts formula. It's in the formula book, as said. And we've set it up nicely here. So let's put into this. We have this is equal to uv. So uv is theta tan theta. I'm going to deal with the limits here. Remember, I'm only working this bit out, so I might as well just try and do as much as I can with that integral with the pi by 3 to 0. Take away the integral from pi by 3 to 0 of v du by dx, so that's tan theta times 1. Okay, well, let's work out the limits of this. That's pi over 3 tan pi over 3. Take away 0 tan 0, which is obviously 0. So I might leave it here because there's too much to do. We can see that 0, but do be careful, particularly in C4 with the 0 bottom limit. It won't always come to 0, but it does here, so I'm going to leave it. And this tan theta integrated is in the formula book. I would explain why it is, but we've got too much to do here, so it's in the formula book, pi over 3 to 0. So working out the pi over 3, tan pi over 3 is the square root of 3, so we've got the square root of 3 pi over 3 here for that bit. Take away ln sec pi over 3. Take away sec of 0. Now cos of pi over 3 is equal to a half, so sec of pi over 3 is ln 2. Sec of 0, so that should be ln of sec of 0. Sec of 0 is equal to 1, ln of 1 equals 0. So we have square root of 3 pi over 3, take away, it's just this bit here, ln of sec pi over 3, so that's equal to ln 2. Okay, so that's the first bit of integral. Now the more challenging one, or the more, is the second one, the integral of tan theta sec squared theta. Right, okay, so, well, it's a couple of ways of going about it, but combinations of tan theta, sec theta can often be used. We can often use kind of an inverse chain rule or standard patterns type thing if we can arrange it properly. One way of doing this is to regard it like this. Just sec squared theta times tan theta. I'm going to write it to the power of 1 like that to see how this works. Because what we've got is we've got an arrangement where it's this kind of reverse chain rule or standard pattern kind of arrangement, which I write now, like that, and we can call it, so this can be our fx, and therefore we have our f stroke x here. So in which case we're just adding, and we've got a power 1 here, so we can use this standard pattern. It's basically reverse chain rule, which you'll see in a moment. So that's equal to add 1 to the power half tan squared theta. Okay, and it's worth checking. If I was to differentiate that, I'd times by the 2, which would cancel, and which would give me the, and I'd take 1 off the power, which would give me tan theta, and then I would differentiate the tan theta, which would give me the sec squared, between the limits pi over 3 and 0. Okay, so that equals to half tan squared pi over 3. So that's equal to half times by the square root of 3 squared, which is equal to 3 over 2. Okay, so we've done the two integrals. Incidentally, this caused a bit of trouble from some of my students, and some of them pretty good students who, despite not being able to do this, still got A stars. But one student had a bit of a dose of paranoia and thought they got it wrong. They did it a different way. Tan theta sec theta. They wrote it like this: tan theta sec theta. I got that properly. Sec theta times by sec theta to the power 1, and then it's also of this reverse chain rule type, but this time sec theta is the thing to the power, and we get half sec squared theta. Doesn't feel like it should be the same thing, but when you put the limits in, it does come to the same, because that will be half, so this is almost like an alternative, or half of sec squared pi over 3, take away half, this is a case where the 0 doesn't come to 0, sec squared 0, which is equal to sec squared pi over 3 is equal to 4, so that's 4 over 2 minus half, which also comes to 3 over 2. So that's an alternative. Anyway, went to town on that a bit, almost forgotten what the question was, which was to find the area, which was that. So the area, let's bring this all together, equals to 3 integral of pi over 3 to 0 of tan theta sec squared theta d theta plus 3 times the integral of theta sec squared theta d theta. We've worked out all of these integrals now. So that's 3 times this one, so that's 9 over, this one is 9 over 2, plus 3 times this one, which will be square root of 3 pi, because it's 3 times that with the 3 cancelling, take away 3 ln 2. So that was it, that's the final answer. Quite a bit to do, not the easiest of things, not the easiest of papers, not the hardest either, but probably harder than average. Hope you found the video useful. Probably my last ever C4, and it was okay. Thanks very much. Bye.